For example 6.6.4, we're using the normal distribution again. There are approximately 1 billion smartphone users in the world today. In the United States, the ages 13 to 55 and over of smartphone users approximately follow a normal distribution with approximate mean and standard deviation of 36.9 years and 13.9 years, respectively. Let's take a moment to write those things down. An approximate mean, 36.9 years, and standard deviation, 13.9 years. Sometimes putting the units on there can help remind you what it is you're looking for or what it is you're given in the problems too. For part A, determine the probability that a random smartphone user in the age range 13 to 55 plus is between 23 and 64.7 years old. It's a little awkwardly worded, 13 to 55 plus. 13 and over would be sufficient, but for some reason it's written this way, so we'll roll with it. Between 23 and 64.7 years old. So let's start with part A and write out that probability between 23, 64.7. Start out with a graph, put the mean in, 36.9 for the year. And now on that number line, we can pick an area left of 36 and put in 23 because 23 is less. On 64.7, somewhere above 36.9. So we want to calculate the probability between those two. We need to do two normal calculations and subtract them. So I'll write them out and then we'll do them in Excel right after. So we're going to do a norm.dist, larger number first, 64.7, mean, standard deviation, and true, minus another norm calculation, norm.dist, smaller number, 23, same mean, same standard deviation, and true. Now let's head over to Excel and see what those calculations will give us. Let's see if I can put them on the same screen at the same time. Alright, up at the top, equals norm.dist, 64.7, 36.9, 13.9, and true, minus norm.dist, 23, 36.9, 13.9, and true again. And when we do that, we get 0.81859, which would round up to 0.8186. So 4 decimal places, round up to 0.8986 for part A. For part B, determine the probability a randomly selected smartphone user in that age range is at most 50.8 years old. At most means that 50.8 is the biggest, which means our randomly selected user needs to be smaller than that. At most, we don't want to go more. We want less. So again, another graph. 36.9 for our mean, somewhere in the middle. And 50.8 somewhere over to the right. And in this instance, we're looking for all of the area to the left of 50.8. And areas to the left are pretty nice. They're just a single norm.dist calculation. 50.8, the mean, the standard deviation, and then true at the end. So pulling up Excel, we can calculate 50.8, 36.9 for our mean, 13.9 for our standard deviation, throw in that word true, and we get 0.84134, which to 4 decimal places, 0.84 0.13. For part C, find the 80th percentile of the distribution and interpret in a complete sentence. All right, we can do this. 80th percentile. This is finding the value k such that the probability that I pick someone and their age is less than k is 0.8, or that 80% of my users are less than this value. Well, since we're given the probability this time and we're looking for the corresponding x value, our picture is still pretty much the same, 36.9. But this time when we pick a value, we don't know what k is. I know that it has to be bigger than the mean because it's the 80th percentile. I have 80% or 0.8 probability to the left of this k value. So the area to the left of k is 80%, which I already know. I need to find k. This is that inverse norm problem. So norm.inv, we'll put in 0.8 and our mean and our standard deviation. And we'll get Excel to calculate it. One thing to point out when you're reading through the book, anytime you see the book reference an INV norm, that's the same as this function. It just has a little bit different notation because it's a different technology with the graphing calculator. But it's the same function. It'll create the same outputs. And we get 48.6, 48.598, we'll round to 48.6. And just as our mean is in years, this is in years. We can interpret this in several different ways. One of them for the 80th percentile, giving myself a little bit more room here. For the 80th percentile, we can say 80% of the smartphone users are 48.6 years or younger. We could also say something along the lines of the probability that I select someone who is 48.6 years old or younger is 80%. That's an equivalent interpretation of what's going on. And a quick recap, norm.inv for Excel and Google is exactly the same as INV norm in the TI calculators that's in your book. The norm.dist function that we use over when we're looking for probabilities is exactly the same as the normal CDF that you see in the book for the TI calculations. So we have an equivalency between the two technologies that we can take advantage of.